So today we will talk about the topic which is the water potential. So basically now what is water potential? The free energy, or you can say the potential energy of the water is known as water potential. The potential energy of water is known as water potential, or you can say the free energy. The free energy of water is known as water potential. Now basically you can write another definition: the ability to lose water. Ability to lose water is known as water potential. For example, I have two glasses, right? This is the high, this is a low. This has high, like this is fully filled and this is half filled. Now which glass you think can lose more water? So obviously you will say that this glass which is fully filled will have the ability to lose water, lose a lot of water. So exactly, this glass has high water potential. This has high water potential because it has a greater ability to lose water. Any, you can say, water which can lose water, which can lose a lot of water has high water potential, right? Now you can also write definition that the difference between the potential energy, or you can say the difference between free energy of pure water and solution is known as water potential. The difference between free energy of pure water and solution is known as water potential, right? Or you can say basically this water potential, this free energy helps the water to flow. This helps the water to flow, right? For example, if we talk about the pure water, so it has the maximum water potential. It has maximum water potential. You can say it has the highest. You can say it has highest water potential, which is 0, right? So the unit to measure this water potential is basically Pascal, or you can say megapascal, right? Or megapascal, or even bar as well, right? Now usually the water potential is less than 0. So water potential is negative of solution, right? So the sign which is used to represent this water potential is known as psi, where P is silent. So this is the sign which is used to represent the water potential, right? Now this water potential, like water flows from high water potential to low water potential, to lower water potential. Now what does that mean? Now we consider, like if I say that there is high water potential, what does that mean? Consider this is a glass, this is another glass, right? It has a lot of water potential. It has the water potential is high, and here the water potential is low, right? What does that mean? That if I say the water potential is high, it means the ability of this water to lose is more. Okay, it means if there's a lot of water, then the concentration of the solution is less. If water is high over here, it means the solute concentration is low, right? Here if I say that the water potential is low, it means the water concentration is low, it means the solute concentration will be high, right? And we know that water always moves from lower solute concentration to the higher solute concentration. Like water always gets attracted towards the high solute concentration. So now here the water will move to this one jar. The water will move to this one jar. Why? Because here the concentration of solute is greater. So that's why we say that the water always moves from high water potential. You can see over here the water potential is high. So the water potential, like water always moves from high water potential to the low water potential, right? Now, one more thing. This water potential is inversely proportional. Water potential is inversely proportional to the amount of solute. Amount of solute. The water potential is inversely proportional to the amount of solute. It means whenever you will increase, if you will add the solute, the water potential will decrease. Okay, consider that this is a glass. It has high water potential. It has high water potential, right? But if you will add solute in it, if you will add the solute in it, now the water potential will basically decrease. The water potential will decrease, right? Now let's talk about the solute potential or osmotic potential. Solute potential. Now what is this? Basically the addition of solute is known as solute potential, but by lowering the water potential, addition of solute by lowering the water potential is known as solute potential or osmotic potential. Right, now what does that mean? If you will add, obviously what we have discussed over here right now, that if you will add the solute, the water potential will decrease, right? So here the same thing is, if you will add the solute, the water potential will basically decrease. But keep this one thing in mind, that okay, the solute potential is denoted by psi s, and it is always in negative. Right? Basically the pure water, the osmotic potential, or you can say the solute potential, osmotic potential and the solute potential both are same thing. Osmotic potential of pure water is 0. Osmotic potential of pure water is 0, and the osmotic potential of distilled water is also 0. Distilled water osmotic potential is 0, right? Now keep this one thing in mind, that as I said that this osmotic potential is always in negative, right? It means that basically water potential is directly proportional to solute potential. Now what does that mean? Basically you have to keep one thing in mind, which is this negative sign. What does that mean now? Okay, if I say you that basically if I say you that something is water potential, solute potential is minus water potential is minus 2000, and his solution A, and his solution B, in which the water potential is minus 3000. Right, now water will move from where to where according to you? We have discussed that water always moves from high water potential to low water potential. So keep one thing in mind, that here it is negative sign, right? Now minus 2000 is greater or minus 3000 is greater? According to me, this minus 2000 is more greater than minus 3000 because it has negative sign. So what we have discussed, that water will always move from high water potential to the low water potential. So water will move from here to here, right? Now it means this has the high water potential. This thing has high water potential, right? Now if I say you that in order to explain you this negative sign, that if I say you that there is high osmotic potential or high solute potential, what does that mean? Basically, if you will increase, as there is inversely proportional sign, there is a negative sign. If you will increase a solute particle, then the osmotic potential, or you can say the solute potential, will basically decrease because there is a negative sign. So something, if it the value in the negative is always greater, right? For example, if I have minus 2000 minus 3000, so which one is greater? Minus 2000 is greater. Same as here, if you will add the solute in it, right, the solute potential will increase, right? But increase in what? Increase in negative, and increasing in negative is automatically decreasing. So we say that the basically the solute potential will decrease. If you are adding the solute, so obviously the water potential will also decrease, so the solute potential is also decreasing. So here we say that the water potential is decreasing. Why? Because if you add solute, the water potential will decrease. If you add solute, so we say that solute potential increase, but increase in what? Increase in negative. Increase in negative, and increasing in negative is automatically decreasing, right? This is how these both are directly proportional, right? So I hope this is clear to you, this osmotic potential and this this water potential. Okay, now water always moves from lower osmotic potential. Water moves from lower osmotic potential to high osmotic potential, right? Okay, now let's do the example as well. For example, if I have, this is a solution A, and it has water potential minus 20, it has solute potential minus 600. This is solution B, it has water potential minus 30 and solute potential is minus 1000. Now if we see this water potential, according to you, water will move from where to where? We have said that water always moves from high water potential to lower water potential. This is low, this is high, so water moves from high water potential to the lower water potential, right? But okay, in case of water potential, during the problems, in case of water potential, you will see this negative sign, but when you will talk about this solute potential, you will neglect this negative sign over there. Now 600 is greater or 1000 is greater? Obviously 1000 is greater. We are neglecting this negative sign over here. So we said that water always moves from lower osmotic potential to high osmotic potential. So 600 is higher, lower, and 1000 is greater. So water will move from lower osmotic potential to the high osmotic potential, right? So I hope this is clear to you. If you have any kind of queries, you can ask me in the comment section. We're really glad to answer you guys.